Okay, so make sure we know again. Again, this is review from Integrated 1 in the first semester of Integrated 2. So if we want to remember, our formula for a linear equation is f of x equals mx plus b. Write this down just so you remember in your notes. Remember, your notes are always writing everything I write. Remember, the slope is the rate of, or the m is the rate of change. Okay, so in this case, the rate of change is the 2. The b is the y-intercept. Because if I plug in 0 for x, because that's the value of x on the y-axis, x is 0 on the y-axis, and 2 times 0 minus 3 is just the b value, which is negative 3. Any questions over that? Now find f of 3, that just basically means that x equals 3. Find y. So into this equation, we're going to take f of x equals 2x minus 3. We're just going to replace all of the x values with 3. So I'm going to get f of 3 equals 2 times 3 minus 3. So I'm going to get f of 3. So f of 3 equals 2 times 3 is 6 minus 3. So f of 3 equals 3. Any questions over that? Okay, let's apply the same things to row number 2. Does anyone think I have the right change for the number 2? Yep. Very good. The rate of change is 1/2, because x over 2 is like a 1 in front, so it's 1 over 2, which is 1/2. Can we class it's the y-intercept here then? What is it, class? 1. There we go. And then we're going to get f of 4. Yeah. 3? Do you agree, class? Yes. Okay, f of 4 equals 3. Any questions over that? We're all good? Okay, the next one we're going to find out some information just looking at the graph. Okay? Remember, the rate of change is just our values over our run. So we're just going to see where we'll find a point. It doesn't matter what point you start at. I'm going to start here. And let's see how far up and over I have to go. I went up 1 and to the right 1. So my rate of change is just 1 over 1, which is just 1. Any questions over that? Okay. So what is the y-intercept here? Very good. It crosses the y-axis right here at negative 3. Okay. And then if we find f of 5, again we're just going to go to where x equals 5. And x is 5 right here. Okay. And then you're going to go up to see what point that is. And that point is 5 for x and 2 for y. So when f is 5, f of 5 is 2. Any questions over that? We're all good? Okay. Okay, does anyone share their story that they wrote? Go for it, Brandon.
Okay, the x-axis, the one that's like this, that's the second. That's the y,
Okay.
And the graph is a car accelerating
Mhm.
from 1 to 6, it is in first gear, and when it's in 6 to 8, it is shifting gears. When it goes from 9
Oh.
to 12, it's in second gear, and from 12 to 15 is braking.
Very good. It's slowing down, slowing itself down, right? Good one. Okay, so this was in units, you said seconds for this? For the x-axis? And then this one is speed?
Yes.
It's hard to write plants like that. Okay, anyone else want to share a story? That's a good one. That works with this. Go for it.
On the bottom, it's time in minutes. So
Okay.
the side heat in Fahrenheit.
Oh.
Put a pie in the oven and turn it on. It rose 3 degrees in 6 minutes, and then it stayed 3 degrees for 2 minutes, and then it rose to 7 degrees on the 12-minute mark. Then her oven broke, and it dropped back to normal degrees in 2 minutes.
Okay.
You can tell that 11 is good.
Very good. Or you turn it off because you have to run to the store and go buy something.
No,
It broke. It broke.
no, we need a
So
new
sad. Need a new oven? Okay, okay. Very good. Okay, another story.
Alright.
Go for it.
It's Hillary's campaign popularity.
Oh my gosh.
So, the bottom is time in months.
Okay.
And then the side is people, but each one is 100,000 people.
Okay.
So, it goes up right after the election, when she doesn't win, just shoots right down.
Okay. Okay. So, but we have to talk, it didn't just go up, right? What happened here?
Right there, she was,
Had more and more people.
yeah, and then she said something, something that some people didn't like, and so she didn't like race, and then she said something she liked. Right
She didn't
there,
do friends.
she started supporting the gays and, yeah, and then they just
So she did have a time here.
right up.
And then she was growing, and then something happened here.
Yeah,
And where?
and then she just,
Yeah.
everyone is like, oh man. And then, yeah, because there's still some people supporting her.
Oh, yeah.
That's, it's still like 100,000 people supporting her.
Yeah.
But,
Very good. Okay. That was very interesting. Okay, so the key here is just that you see that over time, the graph is changing. Things are occurring. I love that you guys all saw that this meant it was going down or being negative, basically, because it went back. Okay? Exactly how I interpret this. And again, you guys can do a million different ones to talk about. We've had distances from school, people talked about, and this was time. We had, what else do we have? You can have this be stock market. This is days, and this is the cost of a stock. Okay? So there's various ways for you to talk about this. The key is I want you to see the different pieces and what's occurring at each time. This is what we call a piecewise function. Okay? It's new to you. You guys haven't seen piecewise before, but this is it. Because the parts are all functions, but they don't go on forever. They have a beginning and an end, usually, and each of the pieces will change as we go. Okay? So let's scroll down. Okay, if you were to write an equation to match the graph, how many different equations would you have to have? How many different linear equations would you have to have for that graph? Yes? 4 equations. You'd have to have 4 equations. Because there are 4 different rates of change. now we're going to come up with a writing equation for each piece of the graph. Okay? We want to divide this up into 4 parts because we have 4 different equations. So just try to make these evenly divided. Okay, so this is going to be equation number 1. Okay. You need a point. Oh, sorry, I shouldn't say a point first. You need a slope first. Or a rate of change. Slash rate of change. And the y-intercept or a point. Okay. You're not always going to be able to see the y-intercept, so if you can't see the y-intercept, find a point on that line. So you need a slope or a rate of change, and a y-intercept or a point. On that first line, if we look back, okay, this is number 1 that we're going to look at right now. Let's start by finding the rate of change. How far up did I move versus how far did I run? I went up 1 and then to the right 2. So my slope here would be 1/2. Any questions over that? Okay, then we're going to go back and see if we can find the y-intercept or a point. So let's go back. Can we see where it crosses the y-axis, this line right here? Yasmin, what do you think? Well, if it crosses the y-axis at 0, right here. Okay. No, it's not your question. Okay? The y-intercept is 0, the b value is 0. So then you just need to plug the rate of change and the y-intercept into our slope-intercept form. The f of x equals mx plus b. Okay, so we just take f of x equals my slope of 1/2 or my rate of change of 1/2 times x plus the b value, which is 0. Okay, and that's your equation of that line. On a test, you want to go one like this, or a probably one like this. You don't need the plus 0, it's just implied when you have nothing being added to it. Any questions over that? We're all good? Okay. Next one, so now we're going to do the line for number 2. Okay, this is number 2 right here. This piece. Oh wait, I forgot something. Okay, on this, we need to talk about the domain. Okay? I'm going to have to move some space over here. I'm going to have to put domain over here. Okay, the domain of this function. Here, if I say that f of x equals 1/2 x, that implies that it goes on forever. That it can go to negative numbers and it can go forever to big numbers, okay? And that's not what happened on my graph. It had a beginning and an end. Oopsie. It had a beginning here and an end here. Okay? So where did it begin at, class? And where did it end at? 6. Okay, the domain of it is the x values, so that's what I'm looking at. I'm not looking at the y values for the beginning and the end. I'm looking at the x values. So it begins at 0 and ends at 6. So domain is your x values. Find the beginning and the end. So we began at 0, okay, and we ended at 6. X goes in the middle for the domain, and we'll have a less than or equal to sign and a less than sign. Okay. The middle point usually stays exactly the same, except for when you're dealing with like a real life scenario. Okay. When they have like a word problem, then you have to worry about when can it equal 0 and when can it equal 6. If not, then you're just going to remember to have 0 is less than or equal to x is less than 6. And that is your domain for this. Because my time can equal 0, and my time at 6 is going to start to change. The rate of change is going to change at 6. So up until 6, the rate will be 1/2. At 6, it's going to change to the next equation. Does that make sense? Okay. Now, next one. Go to number 2. And that's this right here. So here to here, how far did I rise? I didn't rise any at all. So my slope would be 0 over 2. Okay, so I'm going to find the rate of change first. Then I'm going to find either the y-intercept or a point. Can I visually see where this y-intercept would be? It's not there, but I could probably see where it's going to cross. Class, we're going to cross the y at 3. Right? It's going to continue to go this way if it wasn't showing to just that distance, that time limit. Okay. So the b value, the y-intercept would be 3. Okay. So again, you plug it into f of x equals mx plus b, and you'll get f of x equals 0 over 2 is just 0. So 0 x's plus 3. Any questions? Yep. We just put 0. I used the 0 over 2 just to, because you could be 0 over 5, 0 over 15. It's still going to be 0. I just want to reiterate that 0 divided by anything is 0. Okay. So then we're just going to simplify this. We're going to get f of x equals 0 times anything is 0. So I'm not going to have an x. I'm just going to have it equal 3. F of x equals 3. Okay. Do we have to worry about the domain again? beginning. This is going to stay consistent for us right now. And the end. Beginning and end. So let's go look back at our graph. Where is the beginning here? At 6, and where is the end? At 8. So 6 and 8. And again, right here at 6, you're going to be having a slope of 0. As you get to 8, it's going to change. So as it approaches 8, it's going to have a slope of 0. But on 8, it will not have that same slope. So that's why you need it can't equal the 8, it can only be less than 8. So this is 6, and this is 8. Any questions over that? Okay, number 3. Number 3 is new. Let's find the slope. Everyone go look at the slope and find the slope for number 3, our third line. So this is number 3 right here. Okay, what is it?
What does the manager be used for?
It shows what limits are there. That's how you can see that this line's not going to go on forever. Okay? It limits it to only this part of it. Okay? And that will be, as we write the piecewise function, we need the domain for it. Okay. John, what's the slope of that one? Very good. Up 1 and over 1. So my slope, I don't know why I put 3 there. So my slope is 1 over 1, or 1. Any questions over that? Okay, the next step is the y-intercept. So we're going to try and find the y-intercept. Can I see where it crosses the y-intercept? Not really. It's going to be kind of hard to kind of guess. Okay, so we can't use the y-intercept, so we need a point in this case. Okay. The best point to use is usually the beginning point or the end point. One of those 2 points. I usually use the beginning point because they're usually smaller numbers. So 8 for x and then 3 for y. So I'm going to use this point since we don't have the y-intercept. Okay. Now since you don't have the y-intercept, you can't use the y equals mx plus b because you don't have that b. Okay, so we have to use a different formula. Okay. We're going to use the point slope formula. To write the equation. Okay, does anyone remember? I'll be very impressed if you do. Remember the point slope formula. Yes?
Does it start off with like y1 minus y2 or y2 minus 1?
Okay, so that's the slope formula you're thinking about.
But then you do this over.
Okay?
Underneath it is like x minus x.
That's the slope formula,
That's not the point slope.
not the point slope.
Oh.
Anyone else? Any ideas? No? Okay, you're going to remember it, or you're going to be like, oh, okay, I kind of familiar with that. Yeah?
X squared.
No, x squared, because it's linear. X squared means quadratic, right? It's y minus y1 equals m times x minus x1. So that sound familiar? Okay, that's the point slope formula that we learned last year in Integrated 1. Okay, we did not cover it this year. Okay, but that's how you write the equation of a line given a slope and a point. The y1 and the x1 is your point. The m, of course, is your rate of change or your slope. Okay. This y and this x are just your variables, x and y, because your equation should have an x and y in it. Any questions over that? We're all good? Okay, let's plug in. Y minus, this is your x1, this is your y1. So the y1 is 3 equals your slope of 1 times x minus the x1, which is 8. Any questions over that? Okay, you didn't have to solve it and set it to make it equal to y. So we're going to distribute the x. Distribute the 1 to the x and to the 8. You're going to get y minus 3 equals x minus 8. 1 times x is x, and 1 times 8 is 8. Okay, I'm going to get that y by itself, so you're going to add the 3 to both sides. And you're going to get y equals x minus 5. And there you go. That's the equation of that line. Any questions over that? Okay, we're not quite done because we need to find a domain. It's thinking about it. Give me a second. So again, we wait a beginning part and an end. So to go back to that third equation. Now where does it begin and where does it end?
It begins at 8 and it ends at 12.
12, very good. So this is 8 and this is 12. Any questions over that? Okay, do the fourth equation right here. In your parents work on that? Most of us came up with our slope. Okay, we talked about going down one and over one, so our slope is -2 because we're moving down. Okay? If you're going downhill or back down to a smaller y value, that is a negative slope. Okay? So our slope here should be -2. Your point is that starting point. Oopsie, too far. Which is this point here. Somebody use this point, and that's okay, we'll get the same answer. Okay? I use this point, which was 12 and 7. 12 for x and 7 for y. So 12 and 7. Then I plug it into the y minus the y1 equals m times x minus x1. That's going to give me y minus 7 equals -2. This is it. The only way I can plug in the -2 for the slope. Substitute the m with -2. And that gives me x minus 12. Then you have to distribute the -2. And get y minus 7 equals -2x. A negative times a negative is a positive 24. Any questions over that? Okay, we're going to add 7 to both sides. And we're going to get y equals negative 2x plus 31. Any questions over that? Carry on to the domain. Okay, we're going to start and stop somewhere. Class, on that line where we start at 12 and end 15. 12 and 15. Because again, we want that line to have a beginning and end. It doesn't go on forever. Any questions over that? Okay, let's do one more. Okay, now we're going to actually write the piecewise function. Okay? We haven't seen this yet, so I want to make sure you know what a piecewise should look like. We've done all the pieces of it, but we haven't put it all together. So that's what we're going to do here. Now, your graph has 4 parts. I realized after doing it with a class that that's too many, that you don't have enough room here. Okay, so I'm going to do the first 3 parts. Okay, so just pretend like your graph stops at the 3rd one. At that 4th line, just ignore it, okay? Does that make sense? Okay, so a t-shirt company charges $20 per hour for the first 10 shirts. After 10 shirts, they charge $15 per shirt. Then after 20 shirts, they charge $10 per shirt. Okay, we have a piecewise function, P of X, for the total cost of the shirt for X number of shirts. Okay, so we're going to write 3 equations. Okay, we need to leave some space at the bottom, so I'm just going to have you guys draw a line towards the bottom that you're not going to line, because this is where we're going to write the piecewise function. That's where we're going to put our order. So we squeeze in our 3 equations right here. Okay, so that's our first one. We want to find the slope and the y-intercept. Okay, everyone in their pairs try to come up with a slope for that first one and the y-intercept. Let's see what we think of our slope. Kind of a geometry slope. So again, 100 over 5. Because we want 100 and over 5. Notice what you're counting by. You're not counting by ones, you're counting by, here you're counting by 100s, here you're counting by 5s. Okay, which reduces to 100 over 5 is just 20. Which is also how much my shirt costs. Notice, $20 per shirt is the rate of change, so it's 20. That first one is just 20. You can just look at the problem and see, come up with that rate of change. Or you can use the graph, however you'd like to. Okay. And why does it cross my y-axis, class? At 0. My y-intercept is 0. So this one is P of X because that's what they told us to use. P of X equals 20x plus 0. Which just means P of X equals 20x. Any questions over that? Then we have the domain. Okay, the domain might be easier to find in here. Okay, a t-shirt company charges $20 per shirt, so your rate of change is 20 for how long? How many shirts can I buy for $20 a piece? 10. Okay, so am I get -1 shirts? No. So where am I going to start at? 0. Can I buy 0 shirts? Yes. So it has an equal sign. Okay, for the 10 shirts, how much does the 10th shirt cost? $20. All 10 of them cost $200, but just that last one costs $20. So its rate is equal to the 20. So it needs a less than or equal to sign here. Because 0 is less than or equal to x is less than or equal to 10. Does that make sense for the domain? Okay, next one. Let's do number 2. Find your slope. Okay. So it's kind of hard for you to figure out. Here's the one spot here, so how do I get down? I'm going to go up and over. How far did I move up? I started at 200, and I ended at 275. I'm counting at 25. So from 200 to 275, how much did I move? 75. And how far did I move to the right? From 10 to 15 is 5. So my slope would be 75 over 5, which is just 15. And again, if I look at here, it tells me the rate of change, 15. So I could just look at my word problem. Any questions over that? I do not know the y-intercept here, so I need a point. So I'm going to use this point right here. Oh my goodness. My point is, it doesn't like me right now. 10 and 200. It's dying. Give me a second. We'll pause. Okay, so the point would be my 10. Oh, this is going to be so hard. And 200? Okay, there's my wonderful writing right now. Wow, let my thing charge for a minute. Okay, so I go into your formula, or point slope formula, and come up with your answer, please. Can we wait till we're done with this, or how bad is it? Okay, if you can't, you can go, but if you can wait, because we're almost done. Once you plug it into the point slope formula, you should have this. Y minus 200 equals 15 times x minus 10. Who got that far? Okay, good job. When you distribute it, then we're going to get y minus 200 should equal 15x minus 150. Okay, any questions over that? Okay, so the last thing we'll have is just right here. It's going to be y equals, add the 200 both sides, 15x, and then 150, negative 150, and a positive 200 is positive 50. Okay, any questions over that? Okay, go to the other line. No, it's not going to be right. Okay, so this problem, where does it start? So this line, it starts at 10 and ends at 20, right? Okay, so it's going to be 10 is less than or equal to, okay, it's not going to equal 10 because the 10th shirt costs $20. The 10th shirt does not cost $15, so that's why it's not going to have an equal to sign underneath this. Okay, so 10 is less than X, okay, and then my 20th shirt is going to cost $15, so it's going to equal, it's going to equal 20. Any questions over that? Can you read my weird writing? It's okay. We're good. Huh? Did I want to keep what? Yes, I do. Because we have notes. Any questions over that? Okay, so let's do number 3 now. The last one for what I want to do for this problem. Okay, again, your slope should be right here. Your slope is $10, right? Frankie, are you with me? Okay.
Yeah.
Okay, making sure. Your slope is $10 per shirt now. You're going to do the line change is $10 per shirt. Okay. Again, on this one, I can't see where it crosses the y-axis, so I need to find a point. So I'm going to use this as a point. And on it's 20 shirts, and they cost $350. That's a $3 salary, 50. There we go. Okay. Alright, we're going to apply it to our point slope formula again. I'm going to get y minus the 350 equals my slope of 10 times x minus 20. Any questions over that? Okay? Simplify this down. Everyone try to simplify that to come up with your answer. Equation should be, let's call on somebody. Oscar, would you have the equation? What's the equation? Y equals? Okay, yes? Jeremiah, you have it? What is it? You want to find y equals, yep. Y equals 10x plus 150. Okay? Can anyone not get that? Okay? If you distribute if you distribute the 10 times x is 10x, and then 10 times negative 20 is negative 200, then you add the 350. Negative 200 and positive 350 is 150. Okay? Any questions over that? Here too, like, it's gonna be fun, so I can. Okay, then we need to worry about the domain, okay? This domain is gonna be a little different, because after 20 shirts, they charge $10 per shirt. Is there a limit to how many shirts I can buy? No. So I don't have an end. I only have a beginning. Okay, so my domain is going to be X. Okay. Can it equal 20? How much am I paying for that 20th shirt? Am I paying $10 or $15? Okay, after 20 shirts, they charge $10. So if I have 20 shirt, what am I'm paying? Yeah, so it cannot equal the 20 here. Oh gosh. So it doesn't have the equal sign, it's just less than 20, or not less than, greater than 20. X has to be greater than, not equal to, 20. Because I want any amount of shirts over 20 shirts. Yes?
On our paper, it says after 40 shirts, they charge $5.
Because that's, you have 4 equations, right? And I realized that that wasn't going to fit in this space. So I shrunk it down to 3. Okay, so just class that out. Good question, though. Okay, so now it's going to be fun. Oh, please work. Think about the piecewise function. Okay, so we have other parts of the piecewise function. We just need to see. Oh yay. It came back to me. Okay. So I'm using P of X as my function because that's what they told me to use. You put P of X like this. You do this weird little bracket like this. Okay, so this P of X equals all of this stuff, basically. P of X equals, use the bracket. And you just start with the first equation. And you don't need the P of X because you already have it, so you're just going to use the 20X. So you're going to do 20X. You're going to do your semicolon. And then put the domain. X is less than or equal to X is less than or equal to 10. Any questions over that? Okay, we'll move to the next one. The equation is 15x plus 50, so we're going to put right underneath it, 15x plus 50. And then your domain is 10 is less than x is less than or equal to 20. And then our last one, last equation is the 10x plus 150, so we put that at the bottom. 10x plus 150, and then you put your semicolon and write the domain of x has to be greater than 20. And that's what a piecewise function looks like. And you'll see in your notes that you have so far that this is what we're learning. Piecewise functions. Oopsie.